So this is going to be the third video in the series of videos about fractions. And this video, all on its own, is not that helpful, but it's going to come in handy in the fourth video where we learn how to simplify fractions. Okay, so even though this doesn't seem to involve fractions yet, it's going to be super duper important in the next video. Okay, so we need to review a definition. Factor. Let's say factors. These are numbers that are being multiplied. Okay, and this is going to be a big theme in what we talk about throughout this video, and then again, a really big theme in the fourth video where we learn how to simplify fractions. Okay, so keep this in mind: factors, numbers that are being multiplied. Now, one thing that's going to happen in this video is we're going to talk about things called factorizations. This is a number written as a product of factors. For example, let's say we have 6. I could write 6 as 1 times 6, or I could write 6 as 2 times 3. These right here, the 1 times 6 and the 2 times 3, those would be considered factorizations of 6. Let's think about the number 12. Well, I could write 12 as 1 times 12. I could write 12 as 2 times 6. I could write 12 as 3 times 4. I could also write 12 as 3 times. So if we look at this one right here, I've got 3 times 4, but I could write 4 as 2 times 2. So another factorization of 12 would be 3 times 2 times 2. So again, all of these right here, all of these products of factors that equal 12, those are factorizations of 12. Okay, so this is going to be a big theme in this video. Now, sometimes finding the factorization is super easy. For example, 6 and 12, those are numbers we work with all the time. They're pretty small. Finding the factors that would multiply to give you 12, not so bad. Sometimes the numbers are bigger and it becomes a little bit more complicated. So we have divisibility rules. Okay, these rules can be used to determine if a number is divisible by a specific number. So for example, there's a divisibility rule, really common ones for 2, 3, 4, 5, 6, 9, and 10. Okay, so a number is divisible by 2 if it's even. Okay, and even numbers end in 0, 2, 4, 6, or 8. So if a number ends in 0, 2, 4, 6, or 8, it would be considered even and it is divisible by 2. All right. Numbers would be divisible by 3 if the sum of the digits is divisible by 3. All right. So let's look at an example. So we want to know, is 363 divisible by 3? Well, we take the sum of the digits. 3 plus 6 is 9, plus 3 is 12. And then the question is, can I divide 12 by 3 and get a natural number? Well, yeah, I can, because 3 into 12 would equal 4. So this is divisible by 3. Let's look at another example. Let's look at 512. We want to know, is 512 divisible by 3? Well, 5 plus 1 plus 2. 5 plus 1 is 6, plus 2 is 8. Can I divide 3 into 8 evenly? Well, no. So 512 is not divisible by 3. Okay? So a couple more divisibility rules. A number is divisible by 4 if the last two digits is divisible by 4. So no matter what the number is, if the last two digits in the number are divisible by 4, the entire number would also be divisible by 4. So let's look at 324. We're going to look at just the last two digits, 24. Can I divide 24 evenly by 4? Absolutely. I would get 6. So this number is absolutely divisible by 4. Let's try another one. 1,235. All right. So we want to look at the last two digits and we ask ourselves, can I divide 35 by 4 and get a natural number? So that's like a nice, pretty whole number, no decimal. And the answer is no. 35 divided by 4 is not going to be a natural number. Instead, you would get 8.75. Okay, so in this case, we would say 324 is divisible by 4. 1,235 is not divisible by 4. A number is divisible by 5 if it ends in 0 or 5. All right, so 25, 500, 375, 890. All of those have a last digit of either 5 or 0. That would indicate they are divisible by 5. Divisible by 6 takes a little more work. A number is divisible by 6 if it is divisible by both 2 and 3. All right, so let's go back and remind ourselves of the rules for 2 and 3. So a number is divisible by 2 if it's even, and that just means it ends in 0, 2, 4, 6, or 8. A number is divisible by 3 if the sum of the digits is divisible by 3. Okay, so let's look at this one. So let's look at 1,284. Well, it ends in an even number. Okay, so this means this number is even. So we know it's divisible by 2. So we're good there. But now we have to check to see if it's divisible by 3. And remember, the way you check divisibility by 3 is you add up all of the digits. If the sum of the digits is divisible by 3, then the number would be divisible by 3. So 1 plus 2 is 3. 3 plus 8 is 11. 11 plus 4 is 15. And is 15 divisible by 3? Yes. All right. So this is divisible by 2. It's divisible by 3. Therefore, it is divisible by 6. All right. So you've got divisibility rules for 2, 3, 4, 5, and 6. A couple of other really common ones would be divisibility by 9 and 10. So a number is divisible by 9 if the sum of the digits is divisible by 9. So this is very similar to 3. So let's look at 684. We want to know, is 684 divisible by 9? So what we do is we take all of the digits and we add them to each other. So 6 plus 8 plus 4. Well, 6 plus 8 is 14. 14 plus 4 is 18. And it just so happens 18 is absolutely divisible by 9. Therefore, this is divisible by 9. Okay? And then the last trick we have, these are just the most common divisibility rules. There might be some that are less common. You could Google common divisibility rules and find them. All right. A number is divisible by 10 if it ends in 0. So 200, 570, 1610, those would all be numbers that are divisible by 10. Okay. So just a really quick recap. Divisibility by 2 means the number has to be even, and that just means it ends in 0, 2, 4, 6, or 8. Divisibility by 3, the way you check that is you add up all of the digits. If the sum of the digits is divisible by 3, the original number is divisible by 3. Divisibility by 4. A number is divisible by 4 if the last 2 digits is also divisible by 4. So that's an easy one to check. Divisibility by 5 is another super duper easy one. A number is always divisible by 5 if it ends in a 5 or a 0. Divisibility by 6, you got to check a couple of things here. A number is divisible by 6 if it is also divisible by 2 and 3. So what you check is divisibility for 2, check divisibility by 3. If both work, that number by default is divisible by 6. And finally, divisibility by 9. If the sum of the digits is divisible by 9, the original number is also divisible by 9. And then 10, super easy. If the number ends in 0, that number would be divisible by 10. Okay, so let's go back to that first slide. Remember, our goal in this video is to talk about factors and factorizations. Okay, so remember, factorizations are just a number that is written as a product of factors. All right, so we talked about these divisibility rules because they're going to be helpful in just a bit. Okay, so there's a special type of factorization that is called a prime factorization, and that's kind of what we're working towards in this video. So first, you need to know, what is a prime number? So a prime number is any number other than 1 that has only 2 factors. 1 and the number itself. So basically, prime numbers only have one factorization, and that factorization consists of that number itself times 1. That's it. So consider the number 5. Well, how do we multiply to get 5? The only way we can multiply to get 5 is 1 times 5. What about 17? How do you multiply 2 numbers to get 17? Well, the only way to multiply and get 17 is 1 times 17. Okay, so the prime numbers have only one way to multiply to get them. That means they have only one factorization, and that factorization is that number itself and 1. So what do we call all of the other numbers? Well, all of the other numbers are composite numbers. So a composite number is any number other than 1 that is not prime. So this means the number has multiple factorizations. All right, so consider the number 10. Well, we could certainly write 10 as 1 times 5, but that does not mean it's prime. And the reason it's not prime is because we could also write 10 as 2 times 5. So you can see here, we have multiple factorizations. All right, so again, prime numbers, the only way to multiply to get a prime number is to multiply that number by 1. Composite numbers have multiple ways to multiply to get that number. So 1 times the number itself, and then some other pairing of numbers that would multiply to give you whatever. All right, so that leads us to the big topic here, prime factorizations. Now, just to make sure everybody's super duper clear, a factorization is a number written as a product of factors. So instead of writing the number 12, we could think of 12 as 2 times 6, or 3 times 4, or 1 times 12. But if we look right here at this factorization, what do you notice about the numbers that make up the factorization? Well, we've got 3, 2, and 2. Well, all of these are prime. So if all factors are prime, we have the prime factorization. So every number has a prime factorization, and every prime factorization is unique, okay? So prime factorization, this is a factorization made up of all prime factors. All prime factorizations are unique. And what that means is no two numbers have the same prime factorization. So the way you find a prime factorization is to just play around, kind of like we did over here. We played around with all the different ways we could multiply to get 12, and we found the prime factorization. That could become rather tedious depending on the number. So instead, we're going to come up with a process. We're going to use factor trees to find prime factorizations. Now, everybody can envision a stereotypical Christmas tree. So you have your Christmas tree, you have some kind of tree top or a star, an angel, whatever, and then you have all of your tree limbs and ornaments. Okay, kind of get that vision in your head, a stereotypical Christmas tree. That's kind of what a prime factorization's factor tree is going to look like. So let's say we're looking for the prime factorization of 24. Think of 24 as your tree topper. All right. From your tree topper, you're going to create 2 branches, and the ornaments on those 2 branches are going to be any 2 factors of 24. Never use 1. So any factors of 24 other than 1. So let's say we chose 4 and 6. Well, if 4 and 6 are prime, stop. If they're not prime, keep going. Well, 4 and 6 are not prime, so we're going to keep going. We need factors of 4, anything but 1, so we would come up with 2 and 2. We need factors of 6 other than 1, so we would come up with 2 and 3. And if you look down here at the bottom, everything is prime. So we would say the prime factorization of 24 is 2 times 2 times 2 times 3. You want to put your factors in order. And even better, if all I'm asking you for is the prime factorization, you could even write this in exponential notation. So 2 to the third times 3. All right, let's look at a couple more. Let's look at 200. All right, so think of that as the tree topper. We need 2 factors of 200. Notice that this number is ending in 0, so we know it's divisible by 10. So one of my factors could be 10. That means the other one has to be 20. Now, neither of these factors is prime, so we keep going. Well, 10, we need any 2 factors of 10 other than 1, so I would go with 2 and 5. We need any factors of 20 other than 1, so let's say we chose 4 and 5. All right, if it's prime, just bring it down. If it's not prime, break it down into 2 factors. So 2 is prime, 5 is prime, 4 is not prime. We need 2 factors of 4 other than 1. So 2 and 2. 5 is prime, so we just bring it down. All right, so we want to clean this up a little bit. This is 2 times 2 times 2 times 5 times 5. You want to put those factors in order. And then once they're in order, you could write them in exponential notation. There you have it. Let's do one more. So 360, you could come up with any 2 factors that work for 360. I noticed that it ends in 0, so that means it's divisible by 2, 5, and 10. So let's say we divide this by 10. So I get 10 times, well, 36. I'm going to break down each of these numbers since neither of them is prime. 10 would be 2 times 5. 36 could be 6 times 6. If it's prime, just bring it down. If it's not prime, break it down into 2 factors. 6 is not prime, so I would get 2 times 3. And then what I would want to do is rewrite these factors in order. So let's see, I've got 2 times 2 times 2. Next up, I have a 3. I have another 3. And I have a 5. So I've written all of my factors in order. Now I could go to prime factorizations, or not prime factorizations, exponential notation. So I have 2 to the third times 3 to the second times 5. And if you have any doubts, multiply this out right here. All right, you can take a calculator and you get 2 times 2 times 2 times 3 times 3 times 5. And sure enough, we get 360. Okay, so at this point, this video seems way off the mark. It doesn't seem to have anything to do with fractions, okay, but it really does. Okay, this is going to be a huge video when we get to the 4th video in the sequence, which is simplifying fractions, okay? So don't discount this video, watch it, rewatch it. Make sure you're at least generally familiar with the divisibility rules and understand how to find a prime factorization. All right, see you next time.